Hello everyone. I hope I'm audible and also visible. Okay. Okay, let's wait for a few minutes and then we will start. Great. So basically I'll be showing you today a demo that I have just created with respect to GitLab CI/CD because and first of all I'll explain also why we should be preferring GitHub Actions and GitLab CI/CD over Jenkins or any other platform. Okay. So let's wait one more minute and then we'll start. Hello Alok, hello Ankita, hello Mohammed, Vishwajit, hi Dheeraj. Okay, so let me share my screen and then we can start. Okay, let me know guys, you can let me know in chat if my screen is also visible. Screen is visible guys? Okay. So let me explain you for okay before we jump to like what exactly we are going to do today, let us understand why we should prefer GitHub Actions or GitLab CI/CD over Jenkins. Okay, so let's do a quick comparison with respect to GitHub Actions and GitLab CI/CD, and I'm explaining this based on my own experience. Okay, what like I have seen. First of all, Jenkins, when you want to use Jenkins or want to work with Jenkins, it's going to be very costly for you. How? Because first of all, you have to set up the Jenkins master server. So when you want to set up Jenkins master server, you have to have certain amount of resources. Resources means some amount of RAM, CPU, storage, all those things you should be having, for which you have to pay, right? Secondly, you also have to set up a slave machine where you are going to run or execute your pipeline projects. Again, for that also you need to have resources, right? When we talk about GitHub Actions, so there are two options we have. One is that you could use a private runner. Private runner means you have to bring your own VM which you can add as a runner where you can execute your pipelines. Second option you have, which is you can say public runner, where you can use GitHub hosted runners. Okay, for example, let's say I want to use Ubuntu machine. Now here it's going to be costing something because you have to bring your own virtual machine which you are going to make as a runner. But in case of public runner, you don't have to pay anything. You can use the GitHub hosted machine to execute your pipelines. The question is when we should be going with private runner. So in some scenarios, in some companies, they prefer that everything they want to build, they want to make sure that it exists on their own network. Okay, that means whatever when they are building projects, the all the byproducts should be existing on their own machine. In that case, they want to make sure they are using their own VM as a runner so that they can build and keep everything on their own machine. But when you are not concerned much about this, then you can go with public runner, and public runner here zero cost. That is the benefit. Another thing that I have noticed with respect to GitHub Actions, here writing pipelines will become little bit easier because of existing templates. The templates that we have for GitHub Actions, you can get them easily on GitHub Actions marketplace. So whatever step you want to execute, for example, you want to build a Java project, you want to build a Node.js project, you want to perform Docker building of images, everything, every piece of code you can get very easily using templates. So here writing pipeline will be little bit easier. Okay. In Jenkins also we do have templates. sorry, 1 second. In Jenkins also we have templates. Okay, but again, costing is issues here. Then we talk about GitLab CI/CD. What is the purpose, like when we should be using GitLab CI/CD? So in GitLab CI/CD also we have two options: a private runner to execute our pipelines and a public runner to execute our pipelines. In my opinion, public runner is more than enough. And again, it's going to be of $0. You don't have to pay anything. It comes free and you can execute your pipeline jobs here. The best part is that whatever kind of machine you want to use, let's say I want to build my project on Ubuntu machine, so I can write here that I want to build my pipeline on Ubuntu machine, and it will be getting like your pipeline will be executed on Ubuntu machine easily. So in comparison to GitHub Actions and GitLab CI/CD, in my opinion, GitHub Actions is better because again you get templates which makes everything easier for you to write the pipelines. Okay, so today I'll be showing you an example of GitLab CI/CD, like how exactly you have to do everything. Okay. Okay. So first of all, this is one of the project that I added in my ongoing course, where this project is having front end, back end, and a database, MySQL database. So I wanted to show you like how exactly you can build and execute this project using GitLab CI/CD. Okay, just to show you the stages, what I have added. These many stages are there. Here you can see first stage is install tools, which is going to install different tools. Then we have git leak scan to scan if there is any kind of sensitive data in our source code. Then we want to scan the file system to find out if there are any vulnerabilities in the dependencies that we are using. I'm going to explain everything in detail also. In short, first of all, let me explain. Then we have unit test cases for execution. Then we have SonarQube analysis. Then we have Docker building of front-end image and back-end image, plus scanning the Docker images using Trivy and then pushing it to Docker registry. Then we are going to be updating manifest files, and then we are going to deploy to EKS. Okay. So let me explain you the phases or explain you the exact steps that you need to implement, you need to execute in order to build the project. First of all, you have to set up the repository. Basically, you can create a repository in GitLab and you can push your source code. Second step that you need to execute is set up the runner. Now, what example I want to show you is basically using how we could use a private runner, how we could use a public one. Both of them I can show you, which will be much easier for you to understand. Third steps, you can start writing the pipeline. Okay. And fourth step, we can perform the deployment of the application. Right. Now, before deployment is being done, I need to mention you a very critical scenario, a kind of infinite loop that might get created if you are not doing correctly things. Okay, so let me show you what exactly I have done, because the pipeline that I wanted to show you, I just built it 40 minutes ago. Okay, so let me explain you detail what exactly we have to do. For example, let's say this is our sample project. Okay, so I want to create CI/CD pipeline for this project. First thing that we have to do, we have to go to settings, scroll down to CI/CD, and here you'll be able to see one option that says runners. So this is the section where you can add or create runners. Okay, for that you can click on create project runner. Here you can provide tags. Now what exactly is a tag in runner? So tag basically is the one using which you can identify which of my pipeline stages should run on runner. For example, let's say we have multiple stages. We have, let's say, compile stage, we have test stage, we have build stage, right? So I want that my test stage should be executed on my private runner. So in that case, I need to call, or I need to mention that I want to execute test cases on a runner that is labeled as self-hosted. So you can understand that tags basically refers to kind of like unique identification. For example, let's say I provided self-hosted. So next time if I want to execute my pipeline stages on my private runner, I need to mention that this stage should be executed on a runner that has this label. Next thing, you can simply click on create runner. After you click on that, it's going to give you a detailed steps using which you can make a virtual machine a private runner. So here you can select what kind of operating systems you are currently working in. Let's say generally we go with Linux, so you can select Linux, and you can see other options are also available. Means ki you can make a Google Cloud. From there also you can create runners. Okay. For now we will, let's just say that I want to go with Linux runner, Linux machine. Then you have to scroll down, and here you have to click on how do I install GitLab runner. If I click on this, it's going to give me steps, and here you can see what things being done here. So here, first of all, it's going to install a package. Now this package contains everything that is required for a VM to become runner. Secondly, it's also going to create a user GitLab runner, so that whatever pipeline you are executing, whatever task you are executing, that will be executed or ran with this user. Okay, and then permissions will be set up. So if you look closely, that's what being done here. Okay, so once you have installed the package and configured the user, next step is to register your VM as a runner. That means basically what we are trying to do, we want to connect the VM that we have, we want to connect it to our this one GitLab repo. Okay, so this process we are going to do using runner register, and you can see when you run the command runner register, you will be having two options, two things that you need to provide. First, URL. So you can see our account is hosted on gitlab.com, so that will be our URL, and this token we have to use. Okay, so this token, and once we execute this command and we provide certain details, what details we have to provide? Once we run the GitLab register command, first we have to provide the gitlab.com URL, a token. After that, it's going to ask you the name of the runner, which you can give anything. Let's say I just give the name as runner 1, and then it's going to ask you executor, what kind of executors you want to use. So there will be multiple options, Docker and many other, out of which my recommendation would be to go with shell executor, because shell is something where you can execute most of the commands. Okay, so once you provide this, final command would be to run the command as GitLab runner run. Once you execute this command, if I can show you, you can see GitLab runner run. So if you execute this command, your runners will be started. Okay, and just to show you like how exactly it's going to look when you configure it, if I go to CI/CD in the actual project runners, here you can see runner configuration. So this is the runner that I just configured for my project, this one, and you can see it states that it is online, and this is the tag. So basically, once you configure the runner proper way, it will be visible here. Just to show you from scratch, let me show you from scratch itself. Then it will be much clearer to you. Let's say this is our original project where we want to execute everything. Okay. So to show you, I can go to here, settings, CI/CD, runners, and click on create project runner. Here we will give the name self-hosted, any name you can give, but just remember that this name will be required when you want to execute your pipelines. So I'll just giving this name and click on create runner. Side by side, let me create a fresh machine where I can which I can make a private runner. So I can provide this name as private dash runner Ubuntu machine I'm setting up. Keep here we can select. If you are not having, you can create a new one. Just make sure you are creating RSA type and format should be PEM. Network settings you can create. Just to show you like what are the ports that I generally keep in my security group. If I show you here, in my security group, these are the ports that I generally keep open because these are kind of like ports that I regularly use. So these are the ports I keep open. So once you have selected security group, we can go with storage. I'm going to give it 25 and I'll click on launch instance. So now this VM will be created. Now once we have created the VM, we can make it as a runner. I'll open it, copy the public IP, go to 𝗪𝗶𝘶𝗀 and let me connect to it. So I'll just update the IP because the private key is already same. Okay, and let's go here. So VM is connected. First command that you are supposed to run should be sudo apt update. So meanwhile this is happening, we can go to our this page where we can set up, get the commands to configure the VM as a runner. I can select Linux machine, click on this, make sure you are checking which architecture your machine is using. So for me it's AMD 64. I can copy these commands and paste it on the newly created VM. So once it's going to install the package and binary, next step would be to copy these commands and register the VM as a runner for our project. So let's wait for this to complete and then we can execute the commands. Okay, this is done. And now we can execute the GitLab runner register. Click enter. Here we have to provide the GitLab instance URL. So I can copy this step, this URL, gitlab.com. Understand this very clearly ki there could be two scenarios. Sometimes some companies prefer to keep GitLab hosted on their platform. That means they can deploy their GitLab inside Kubernetes and they don't use the gitlab.com. That means they might be having a different URL. Let's say xyz.gitlab.com, something like that. So here for us, as of now, we are using gitlab.com only. So we'll go with it. Then we have to provide the name of the runner. Let's say I will provide the name as private dash runner. Click enter. Executor. You can see multiple options are available. Custom SSH, Docker, Docker plus machine, Kubernetes shell, Parallels, VirtualBox. So many options. For now, I'll just go with shell because most of my commands will require shell to execute and enter. Right. So now you can see runner registered successfully, right? And we can go here, but here nothing is showing that we have registered the runner, right? So what we have to do, we have to execute this last command which says we'll copy this command gitlab runner run and I will execute it on this machine. As soon as I execute it and we will go back here, you can see here you see this notification that you have registered a new runner. That means now we have successfully connected a VM as a runner to our machine, to our GitLab CI/CD, right? So this is done. But two very important things that we need to understand. Let me explain you before you proceed with the pipeline step. First thing, understand this ki by default when we execute any commands on our VM, for example, let's say like this is my VM, so I execute this all the commands here itself, like I'm having a terminal available to me, right, a screen available to me. But in case of GitLab CI/CD, what is going to happen, it's going to execute commands and execute the pipeline stages in backend, and it's not having access to a terminal. So by default, what happens when you create a user, like as I told you, okay, all these stages will be executed by a user named GitLab dash runner, right? So by default, this user won't be having access directly to a terminal. So what happens when this user gets set up in its home directory, like this will be its home directory. Inside this, there will be a file. In every user's home directory, there will be a file known as like this bash logout. It basically contains some commands that's going to get executed automatically whenever user exits the terminal or bash logout. Now, what command does it have? In our case, it is going to have a command that is going to perform clearing of the screen. But you can understand that when I'm executing my pipeline using GitLab runner user, it's being done like without the UI in backend it's being done. That means ki this cannot get executed, right? Or even if it's tried to get executed, it's going to cause issues for our pipeline. Pipeline might fail. So what we have to do, we have to basically rename this file to something like this, ki bash logout.bkp, anything you can put. So this will make sure ki this command does not get executed and does not need to, because again we are not using a terminal directly, we are using everything is being done in backend. Okay. Second thing that we need to do, as I told you, when I'm going to execute my pipelines, I'm going to execute my pipeline stages. So everything, we need certain tools also. For example, I want to use Trivi, I want to use Gitleaks, right? So these tools I need to install. So one option is that I can manually go into the runner and I can install. Second option is that installation stages, steps we can add inside the pipeline itself. For example, like sudo apt install trivi, right? So if I do this, you can see the problem here that you might face is like usage of sudo, because by default the user GitLab runner. Again, do not forget that we are, whenever we execute the pipeline on our runner, it's going to get executed using the user GitLab runner. So when we are going to be using this user by default is not added to sudoers list. If it is not added to sudoers list, that means ki it's not going to have the permission to execute sudo commands, right? So first of all, what we are going to do, two things. Again, second, in first step we understood that we have to like basically move this file. Second thing what we have to do, we have to first mention that this user does not require a terminal, because again terminal is not required in our case because everything will be done in backend without any UI. Secondly, we have to make sure that GitLab runner user is added to sudoers list so that we can execute or use sudo commands to install certain tools. Question is how exactly we have to do. So let me show you. I'll first of all press Ctrl C to stop the runner. I'll become root user quickly. And here, first of all, let me make the screen bigger. I'll go inside the home directory, then GitLab runner. Now, if I run ls-lart, you will be you'll be able to see that we have a file named bash logout. So it might contain the code that is going to be utilized for clearing the screen. What we are going to do, we are going to be moving this file with to basically a different name. .bkp. First thing done. Second thing that we want to do is basically add GitLab runner user to sudoers list. Now, two options is that we could use the primary sudoers file, or we could use the file that is specifically for GitLab runner user. Both of them we could use, but here this is the primary one, so we don't want to use it. So we will be using the specific file for GitLab runner. So basically we have to execute this command. You can see inside etc folder we are opening a GitLab runner specific file, and inside this we have to add two lines. First, defaults GitLab runner required tty. Now here you can see I'm using a symbol of negation, means key negative. That means key it does not require, it should not require terminal. Secondly, we are adding GitLab runner to sudoers list so that no password is also needed. So we will copy this and we will add it here. We will save this, okay, and exit. Just to confirm, I'll execute the command again and we can see changes are saved. So main things have been done. And finally, we can start the runner again. GitLab dash runner run. So it has started, right? Now we will go back to our pipeline. How exactly we have to write the pipeline? So I have written it, but let me explain you in very detail because it's going to be a little bit complex for everyone. 1 second. start with this one. It might seem a little bit hard right now, but trust me, it's very easy actually. Okay, let's start from the beginning. Also, guys, one thing I should know key today, this piece of code that you are seeing here, it was not required till yesterday. So I did the project yesterday also with a different repo, same project. If I show you, 1 second. This was the project that I did yesterday. It is also successful. And here, if I show you the code, you can see it starts from stages. That means ki in previous version, it was not required. This thing was not required. I'll tell you what changes have been there. First, everything will be getting executed using GitLab runner user, right? By default, GitLab runner user use a token to clone the repository, right? But that is not working today, as per my experience. Like I was trying today also, so it was not working today. So what I have done, first I added variables git strategy, which means ki do not clone, do not do anything. When the pipeline starts, do not do anything. Secondly, what I'm saying, I'm setting up a default script. I'm setting up ki before any of the main scripts get executed, you have to do two things. You have to first define CI project directory. Now, this is a default keyword. It's going to point to basically the workspace, the repository folder structure. Secondly, I'm saying that uh, check immediately if there is already this repository created or not. If it is created, just remove everything. Finally, what I'm doing, I'm running a git clone command where I'm using git clone pat. Pat means project access token. As I say, ki by default, runner is able to clone it, but today it was not able to do that. So for that, what I did, I created my own token, and then I asked to use that token. Now you can see I'm providing user here, and then I'm providing the token here, then the repository. Question is ki, okay, Aditya, these things, CI project directory, this is a default keyword you said, but these two things, CI clone user and CI clone pad, this is not default. So where do exactly we have to create and where we have to save? So what you have to do, you have to go to settings, then access tokens, and you can click on add new token, provide the token name, and you can provide different level of permission. Generally, I give all the permissions. For example, let's say token name, you can give anything. You can select a role, like maintainer would be more than enough to do anything. Let's say I selected these. Okay, so now I have this token available, right? So once I have this token available, what I'm going to do, I will be, if I show you here, I'll be going to settings, then CI/CD. In CI/CD, I'll be going to variables, and here you can see these two things, CI clone pat and CI clone user. So I added these two variables, and in username, my username, which is 𝗪𝗏𝗪246, and clone pat, the token that we just created. You can click on add variable, scroll down here, we can provide the username. Here the key will be CI clone user, here the username. Then secondly, we have to provide CI clone pat, and here the value of it. Once you provide it, then the variables will be added. So once we have added the variable, then basically we are saying key clone manually using this token. So this will make sure key before you execute the pipeline, before you execute the pipeline, the repository is available for any kind of task. I'll show you the error also, ki what kind of error generally I was getting before I implemented this. 1 second. Let me show you the previous builds, that the error actually what I was getting. For example, 2 hours ago I just started. If I open this, so authentication issue will be there. Password was incorrect, or you are required to use a token. Even though by default GitLab user is having permission, but today it was not working. Okay, so this is one of the error that you might get. Then comes the easy part. This is something that you can directly add. Then comes the very easy code pieces of code. Let me explain you. This is quite easy. First of all, what we have to do, we have to define stages. What stages we have? One second. First, we have to define stages, and whatever stages you are going to have in your pipeline, you have to define. For example, I have written install tools, where I have to install 𝗫𝗏, we have to install gitleaks, right? Then we are going to perform the gitleak scanning of the repository. Gitleak scan, what it does, it's going to find out if there is any kind of sensitive data in your repository or not. Sensitive data means sometimes it happens that developer, or like not much experienced developers, they might add or hard code sensitive data like password, API tokens, API keys, or anything like that, the sensitive data. So we can use gitleaks tool to find out if there is any kind of sensitive data added in the repository. Then we have 𝗫𝗏 file system scan, which is going to scan the dependency file. For example, in Java we have pom file, in Node.js we have package.json, in Python we have requirement.txt, in .NET we have csproj file. So these files basically contains information about whatever library or dependency that we'll be using in the project. So 𝗫𝗏 can scan these files and find out key whatever dependency or library that we are going to be using, are they safe or not, are they having any issue or not, so that can be found. Then we have test stage, which is going to which is basically referring to performing the test execution of unit test cases. Then we have SonarQube analysis to find out if in our source code, if there is any bug, any vulnerability, any code smell, those kind of code related issues. Then we are going to be building and scanning the image. So I have the project in format of, we have front end, we have back end, and we have database also. For these two, we have to build Docker images. Once images are built, we are going to be using 𝗫𝗏 to scan it, and then we are going to be pushing the image to Docker Hub registry. Next comes the best part, this update manifest. This is something that where an infinite loop could be created. How it can be created? Let us understand. Let's say this is project repository, okay, and here we have pipeline. Now, inside my pipeline, I have written stages to build Docker images as well, right? So let's say I build the Docker image for front end, and let's say tag was version 1. Similarly, I build Docker image for backend version 2, version 1. I want that these images tag should be updated to my YAML manifest file. Which file I'm referring to? I'm referring to, let's say this is the repository. So inside the repository, we have this K8 as folder. Inside it, we have, let's say, backend.yaml and all. You can see this is the image name. rdjsol/backend main, then a date, right? So if I'm building my project tomorrow, if I'm building Docker images tomorrow, this tag will be changed. So anytime that I'm building it, it should be updated here. Okay. So that is basically, I can once I have built my Docker image, I need to update the uh, value of the tags in the repository. So I can ask pipeline to do that. The problem is that in my pipeline, I have written that whenever any kind of push happens to the main branch of the repo, it should trigger the pipeline. And now you can understand ki if I'm trying to update the image tags which is in the repo, I'm basically what I'm pushing something. So if I'm pushing something, that means that changes have been pushed to repo, which in turn triggers the pipeline again, right? and again pipeline got triggered, again Docker images will be built, and this time maybe different version will be used, and those changes will need to be pushed to repository, basically updating of the tags, and again pipeline will be triggered. So this is what, this is an infinite loop. So what we could do, we could use something known as skip CI. Same format we have to add in our stage, which I'll be showing you in a bit. If I add this, that means that this time when my pipeline is pushing something to my repo, it should not trigger it should not trigger the pipeline. So this saves from the infinite loop. Okay. Now understanding like, and final stage will be deploy to EKS. This is something that you need to watch very carefully, because here if you understood the process how exactly we are doing, then with any kind of CI/CD tool you could be able to, you will be able to deploy the applications. Now let us understand ski how we see. Here we define stage names, ki what are the stages that we are going to have in our pipeline. You can see format is very simple, YAML format we are using for stages, then name of the stages, and then below it each stage we have to define. First, install tool job, right? First you define a job, okay, then below the job you define the name of the stage, then stage, then name of the stage. Note that this name should be same as what you have defined here in install. You can see stage name should be same as what you have defined in stages section, and then you write script, and below script you just have to write all the shell commands. Question is ki here I have to install the tools, what steps I have to get and where I can get, right? So I can show you. First of all, I can go here and search as 𝗵𝗵 install Ubuntu. You can click on the first link, scroll down till you find Ubuntu, and you can see these are the steps you have to copy, and you have to write it directly here. Just remember the format key. You can see you have to use a dash and then write the lines. Each line you have to write separately using a dash, right? And now sudo also will work. Why? Because we have already set up this, we have added the GitLab runners to sudoers list. Okay. Similarly, I have to install gitleaks also. So gitleaks, if I need to install, I can go on any machine. Let's say I'll run here as git leaks. Sorry, here it is already installed, I guess. I will run so you can see from one Linux machine itself, we are getting the command that will be required for installing gitleaks on our machine. So I can copy this command and I can directly add it here. You can see same command I have added. Just make sure to add -y so that no prompt comes to provide the permission for proceeding, right? So in this way you can write first stage. Now here you have to define tags. Tags means ki where exactly I want to execute my pipeline, and as you can understand very clearly that in my case the pipeline I want to build, I have defined in CI/CD runner section the runners, and the name on the label I have given to my runner as self-hosted. So if I write it here below my stage definition that tags is self-hosted, then automatically this job will understand ki, okay, I need to get executed on the runner that has this label available. Which label? Self-hosted. And that is that is something that I have added for my private runner. Similarly, I have to go with gitleaks scan job. Second job stage will be gitleaks scan. Again, name should be same what you have defined in the stages section. Inside script you have to write very simple code, which is gitleaks detect hyphen source, then the path that you want to scan, and then I want that report should be published in a separate file. So I can write -r, then let's say you can write and this result dot text. So now my report will be coming inside this, and I want to make sure that any sensitive data should not be visible in the logs as well. So I will just write -redact. So any sensitive data that might be visible in logs, it is not going to be visible because we have added this. And you can see it's a simple shell command I have written. Okay, format you can understand, it's very simple format: git leaks, stage name, then under script you can write tags we define. But before that, one more thing: needs, then job name. Why I need to define? I have written here needs, then hyphen job, then name of the job, previous job, which is install tools job. Why we need to define this? So basically I want that my gitleaks job should run after this job has completed. That's why I have written needs, then job name. That means ki gitleaks scan job will only run if previous job, the job name that you define here, is completed. Okay, next we have trivy, same format, trivy fs hyphen hyphen format. In table format we want the result, and I want the report inside this file, and I want trivy to scan the current directory. For that I have added dot. Again, need section will be gitleaks scan job. That means ki previous job should be executed only when gitleaks job has been completed. And again, this also I want to execute on my private runner. That's why I'm providing the label self-hosted. Now till here, every all these stages, the install job stage, gitleaks scan stage, and trivy fs scan stage, I have executed on my private runner, right? Now, moving forward, whatever stage I'm going to add, I want to execute those in like separate, in like you can say public runner, not on private. Okay, so let me show you how it can be done. Okay, so after that, what stage we should be having? We should be having the stage for performing SonarQube analysis. Now, if I show you the code for that, you can see this is the code. But initially if you see this, you might understand okay, okay, it looks very complex. And Aditya, where exactly did you get this code? How exactly we can get it? So let me show you. Once you set up SonarQube, you can simply click on create project, local project, provide any name. Let's say XYZ I'm providing. Click on next, custom, create project. And here it is going to ask you okay, how exactly you are going to perform the analysis. So I can select GitLab CI. And you can see here it's going to give you step-by-step instructions that you can use. So what we have to do first, we have to create a token. As you can remember, if you want to push your reports to SonarQube, you have to make sure that you have two things: SonarQube URL and SonarQube token. Again, you can generate from here. It's a generate, and this is the token that you can copy and keep with you. Once you have token available, and once you have sonar host URL. Sonar host URL is what this is. Once you have these two things available, you can understand here that you have to add it to GitLab CICD variable, where we have to add settings CICD variables. How we can do that? We can go to our pipeline, go to settings, CICD, and inside CICD you should be able to see variables. Inside variable section you can see these two things: sonar host URL. If I show you this, you can see the value, the sonar server. Just make sure that you are removing the last slash. Similarly, in SonarQube token also, the token that we create, we can add it here. Once you have added it, then you are good to go, and you can click on here, create or update the configuration file. So let's say even though I have .NET Node.js project, I'm just going to click on other. What is the next step? You have to create a file named sonar-project.properties. Do we have this file present here? If I go to repository, you can see we should be having this file. And inside this file, you have to provide whatever information is giving here based on your project name. So you can see you have to add these two things. Then comes the part from here. Okay. This is the code that you could use, but in my opinion, I have modified it a little bit. Like basically not added something new. I just removed few things, which makes everything the pipeline much easier. So let me explain you what changes I have done. If I show you, uh, and let me explain you also like how exactly it's working. And from here, from SonarQube stage, we are going to execute everything on public runner, not private one. Again, initially it might seem okay, it looks very complex or very hard, but it's not. I have basically just picked up the code from SonarQube itself. Okay. First, what we are doing, defining the job name, which is Sonar job. Any job name you can give, it's completely up to you. Then stage name. Stage name should be same as what we have defined in the stages section. That you need to be very careful about here. Whatever definition we are giving, it should be same. Here you can see SonarQube analysis. So here also it should be stage name like that. Then we define image. Why we define image? Basically, I want that this stage should be executed inside a Docker container. Inside a Docker container. So I need to tell my pipeline stage that, okay, this stage should be executed on pipeline container. Because see, previously, if I want my stage to be executed on a uh, private runner, then I have to define the tags self-hosted. But if I want that my stage should be executed inside a Docker container, then I have to define the image, the name of the image. Now if you look closely, I'm using a specific image, sonar source slash sonar scanner CLI. Why we need to use this image, or is it mandatory? Firstly, it's not mandatory. See, the way that SonarQube works is these two things. You need to have sonar scanner tool and sonar server. So what you saw here, this is sonar server. Okay, here you see projects, these are sonar server. This is the sonar server and these are projects. Second tool that you will be needing is known as scanner. So this is the actual tool which is going to perform the analysis, generate the report, and then publish the report to SonarQube server. So if you have this tool installed on your private runner, then you don't need to have the image. But you can understand that installing scanner is a extra task, extra additional task. Why not simply pick up a Docker container that has this tool pre-installed? That's why we are using this Docker image, sonar source, sonar scanner CLI. So this image, when when a container gets created out of it, it is already going to have this tool, sonar scanner CLI, and that is the benefit. Okay, first thing we have defined. Then we have to mention when exactly it should be executed. Now you can understand that SonarQube performs code coverage as well. Code coverage requires the execution of test cases report. So test cases report SonarQube will be having access to only when unit test job has been completed. So needs I have written as unit test job. Then comes the part cache. Understand this key. Some of you already know cache. So basically, let's say I have executed my SonarQube analysis some time ago. So whatever byproducts were created from that, it could be utilized again, right? And that they will be available in cache format. For example, let's say I'm building Docker image. In building Docker image, I have written certain steps. There was one layer where I was downloading all the dependencies. 10 dependencies I downloaded. Okay. Let's say second time when I started to build my Docker image, same dependencies were required. So does the Docker going to install the dependencies again, or simply pick up from the previous run? It is going to pick up from the previous run. Similar kind of things can be done with respect to SonarQube analysis. For that, we need to define cache. We can define cache, and below cache you have to define the policy. Policy what I'm using, pull and push. Again guys, again I'm saying this is not something that I have written. This is something that SonarQube itself provided for easier run, right? But let me explain you. In policy, when it is written pull and push, what exactly does it mean? Pull means ki it's going to pull the previous run cache. If it is available, it's going to pull it. Push means ki for after the current run has been completed, after the current analysis have been completed, it's going to update the cache to latest. You see here, this will be the name of new cache. With this is referring to the commit ID kind of thing. So pull push basically means ki pull means ki it's going to pick up the previous execution, like whenever previous time SonarQube ran. So whatever cache was available, it's going to pick up that. Push means ki after our current run, whatever cache is created, it's going to push and keep that. Then we are providing path ki cache will be kept here and scanner is on the root directory itself. And then we are running the script. In script, what we are doing first, we are calling the scanner tool. You can see Sonar Scanner. You can simply call a tool by just writing its name, and then we are providing some parameters. First, host URL. Again, it's going to pick up the value from the variable we have added, and then we have Sonar login. So the token will be again picked up from Sonar token variable inside the variables we have added. Here you see this section allow failure true. That means we are trying to say that even the analysis of SonarQube fails. Means ki let's say ki if I show you with an example, let's say this is my project. You can see quality gate passed. I want that even if that failed, if even if the quality gate has failed, I don't want my pipeline to fail. That means ki even quality gate fail, pipeline should proceed further. For that, allow failure true. Next thing what we have written, rules. Rules basically define ki when this stage will execute. Execute means ki when the sonar analysis will happen. So I have written two conditions. First, merge request have been created. Secondly, the commit has been or push has been done to the main branch. And this is the simple as that. Again, you can write it very easily. You can just pick up from SonarQube and you can keep it here. Coming to next thing what we have. So if I show you, next up we have Docker image build, and this is kind of little complex, and I'll explain you why it's complex. Because in the single thing, I have to we have to add lot of things. Single stage, we have to add lot of things. Let me show you. Okay. First, we define job name and the we are going to define the stage name as well. Okay, before we proceed, guys, just to let you know, first of all, this is one of the projects that I have added in my course, and just to let you know, batch 12 has already been started. It's a pre-recorded batch that has, it's going to be having 45 plus projects. Out of those projects, you can easily add to your resume as well. Okay, and again, what you'll be getting 120 plus hours of content, immediate access to that you'll be getting, and you can go through the course. You'll understand ki how deep dive we have been doing. We have, and we are, it's not ki we are covering just Jenkins, we are covering Jenkins, we are covering GitLab CICD, we are covering GitHub Actions, we are covering Azure DevOps pipeline. All four we are covering with proper examples, not a hello world project with multi-tier application with databases. And for general applications, we have been again use 8 kind of applications that I have used, main applications, out of which 4 will be Java, one application Java, one application Node.js, one application Python, one application .NET. Then one application .NET with database, Python with database, different database. All 3 database we have used: MongoDB, MySQL, and Postgres. All 3 database we have used. Just check it out the syllabus. You will be able to understand how deep dive we have been doing. As of now, we are having a discount. That means you'll be able to get the course for 8499. So if interested, you can check it out. You can get all the details in the comment section. My teammate will be pasting the details here. You can check it out. Validity we have increased for this batch to 3 years. Okay, and yeah, talking about how doubt support will be handled for this batch. So there will be a separate Discord server where you can put your queries, and if you want your resume to be evaluated, you can ask there. If you want guidance for resume, you can connect directly to me, and if you have an interview schedule, then also you can connect to me. Okay, so all these things will be included, and trust me, when you go through the syllabus, you will understand that we are not charging that much as compared to how much we have given in the course. Okay, so you can check it out. Coming back here now, Docker, how exactly we are doing. First of all, you can see we are going to be using a Docker image. What's Docker image we are using? Docker 27. Why exactly, and what is the speciality about this Docker image, why we are using it? So we are using this Docker image because it has Docker CLI pre-installed, and moving further, we have to use this very specific service which is known as DIND, Docker in Docker. So first we define this Docker image using which a container will be created. That container will be having a CLI. Secondly, we define a service Docker 27-DIND. DIND means Docker in Docker. Here, what is going to happen? Two containers will be created. One will be having CLI and one will be having daemon. Because see, the way that Docker is going to work, CLI is where you are going to write the commands, and Docker daemon is something which is going to execute everything, going to manage the containers, create the containers. So we'll be needing both the things. So in first container we have CLI, in second we have Docker daemon. That's why we have to write in this format. Then we define variables Docker TLS cert directory, and I'm keeping it, you can see, empty. Why I'm keeping it empty? Because I want to disable TLS, because it won't be needed. TLS will be needed for securing the TCP connection. In our case, what is basically happening, CLI container, the container that has CLI, container that has a daemon, they are running an ephemeral network. That means ki an isolated network and a network environment that is going to get deleted as soon as our task is done. So here, like, TLS won't be required, so that's why I have keeping it empty. Then we define it Docker host, which is this Docker name is coming from the uh, this service name 2375. Why we are using it? 2376 is for TLS, 2375 when we have TLS disabled. And then comes the part of script, like what exactly we have to do. So if I want to execute Docker stage, if I want to build my Docker images, what we have to do? First of all, we have to log in, right? Now, some basic command that you want to log into Docker, you can execute Docker login -u, your username, and you could use a password also. But try to understand here. If you added your password in this format -p and password value, then it will be visible in the log, which we don't want. So what I'm doing here, first of all, I'm using an echo command with a variable Docker password and Docker username. These two variables also I will be adding in the variable section. If I show you here, you can see Docker password and Docker username. These also variable I have added in the CI/CD variables. Okay. Once we have added, first command we are running echo Docker password, and then we are using pipe. We are running Docker login -u Docker username. Then I'm using -- password stdin, means standard input. So what is going to happen here? Echo whatever value this is going to put, it will be passed here as a input, because it's going to ask for password, and immediately password value will be input. Benefit here is that your password won't be visible in the console log, and that is the really good thing. Then comes the part, I want that my Docker image tag should be different. Different means it should be, first of all, branch name, and then it should be having the date on which it is created. So my tag, Docker image tags, will be something like this. Let's say we are on main branch, then it will be like that, 2025, let's say 11, and today's date is 21. So Docker image tag will be this, so it will be much easier to understand also when it is created. So I'm defining the tag here. Then image names I'm defining. First, my API image name, the backend part, client image name, Docker username, which is 𝗬𝗵𝘁'𝗶 𝗟𝗶 in my case, slash backend and frontend. So this is my user image name. After that, here I have to use the tag, and tag is this one, branch name and the date, right? So here till here we have defined like how our image will be looking. Then what we are doing, we are actually building our Docker image. First, I'm building for the API part. Location of the Docker file we have to provide. Again, for front end location we have to provide, and here you can see everything I'm using variable format, because we have already defined API image name defined here, image tag defined here, same thing for client image and image tag. Now once, like, till here, what is going to happen, our image will be built. After that, what we want to scan the image as well. So you can understand that all these things are happening where inside a container, right? So what I'm doing, I'm going to install Trivi there itself. Now I want to install Trivi inside a container. So some of you might think, Aditya, you could use simply this command apt get install Trivi. But the thing is key, the container that I'm using, and in most cases also the container that you work with, they do not have apt. Instead, they have apk. It is another package manager. So now we need to understand that we have to install Trivi using apk because apt won't be present inside the container. That's why I have written here apt add no cache, basically kind of like adding like sorry updating, and then we are downloading the package and basically installing the Trivi. Once I install Trivi, then I can execute these command. And let me explain you what exactly I have written here as well. Here I have written Trivi, calling Trivi, image what we want to scan, hyphen exit code 0. This is very important. So initially I wrote this exit code 1 because I wanted to see. I'll come to that. After that, I have written severity. What kind of vulnerabilities need to be found? Find vulnerabilities only with high or critical severity, and then the image name that I want to scan. Initially, I wrote exit code 1. That means if critical and high severity vulnerabilities are found out in my Docker image, immediately exit the or fail the pipeline, fail the stage. But you can understand as of now, if I want to just proceed with everything, then I can go with exit code 0. That means exit without any error. So in companies, obviously we have to go with exit code 1 because we need to make sure that there is no kind of vulnerabilities in our dependency within the Docker image. So in reality we have to use this, but just to make pipeline successful, I use this. I did both of them for API Docker image and client Docker image. Then tagging. So I want to see here tag we gave date, branch name and date. I'm using latest also. Both of them I'm keeping inside my repository. So I have tagged it here. It's not a mandatory stage, but again I'm just keeping it. So there will be one tag available with the name latest. And then we are pushing all the images, Docker push and the images name. So this is how Docker will be done. And then comes the part where we want to update the YAML manifest file. Updating YAML manifest file basically means that we want to update it every time I build my Docker image. I want to make sure that the tag in the Docker tag in the YAML manifest file, it's updated and it's latest one. So let me explain you what exactly we are doing here as well. Now see, in GitLab, you won't be able to get multiple templates as compared to GitHub Actions, because in GitHub Actions, you do have templates. In GitLab CI/CD, most of the things that you are seeing here, I have written with multiple, like first time I wrote something, then error came, then I have to modify it again. Like that I used to do. Now here what we are doing, uh, this is the job name, this is stage name, image I'm using Ruby 3.1. You might ask, Aditya, why you're using this? Because if I don't define anything by default, this is only going to get used. So just for the visibility purpose, I'm mentioning this clearly. Okay, I want to use this. You could use other images also, like you could use one to latest also. This is also you could use. But this is something that comes by default, so I just wrote it down. Then needs. So I can update the image tag inside the YAML manifest file only when the Docker images build has complete. For that purpose only need section we have added for build image job, right? Then script. Here what we are doing, again image tag we are defining. Okay, why we are defining it here again? Because from previous stage image tag might not be visible here. For that purpose I'm defining it separately again. And then we are using this stream editor command, sed command, to update. What we want to update, we want to update this value. New value should be, tag should be updated in which file? In this file. Similarly, for front end using sed command, we are updating and inside this file. Then we are defining when these changes are going to be pushed inside GitLab repository. with what user and with what email it should be done. So you can define that. Then we are running git remote set URL, and this is something that you have to be very careful about. I'm using this variable, okay, which has the project access token. But before that, since we are using main branch, few changes we have to do. Let me show you what exactly I'm talking about. You can see the token I have added here in variables. Okay, and it is also visible here in access token section, right? Role I have given developer. You can give the role like maintainer or whatever your requirement, you can give that role. As of now, I have given the role developer. Okay, now here in settings, you go to repository, you go to protected branches, and here protected branch is main, and you can see who has the permission to perform the merge and push changes. Developers per maintainers, again developers plus maintainers. By default here it won't be there. Here by default only will be maintainers or no one. So you have to make sure ki the token that you are using, whatever role it has, that you are giving it here, then only your token can be utilized to push changes inside the GitLab repository. So once we have done that, and then only this piece of command can be utilized to set up the remote URL. Okay, after that, whatever file changes we have done, we are going to perform the add commit. Now in commit, this is very important, this section that you see skip CI. This is something that is going to break that infinite loop. Okay, and here this no changes to commit if no changes were done, and then we can push the changes to our main branch. Okay, so till here basically what we have been doing, we have been performing the CI part. Now comes the CD part, but CD part, a very interesting concept I want to explain you, so that if you understand that concept, you could implement it or use it in any kind of CI/CD pipeline. For CD, what we have to do, first step, we have to set up the cluster. I'm using EKS cluster. Most of you might know about kubeconfig file. It's a file that gets created whenever you set a cluster, and it can be a default file will be there, but if I want to basically this file contains information about the cluster. It contains a certificate authority data that can be utilized for communication between different components within the cluster. So this file can also be used for authentication. That means if I want to perform deployment to my cluster, if I have this file, then I could perform the deployments, right? So what we have to do, so when we after we have set up EKS cluster, two things I'm going to be doing. Let me show you quickly. One second. Okay, what we have to do, we have to set up RBAC. RBAC is what? Role based access control. Now let us understand what exactly do we mean by that. So basically, when you set up cluster, by default admin credentials are available, and I can perform things with admin user permission. And you can understand that admin has all level of permission to do everything, to even delete the cluster itself or to make any kind of changes, right? But you can understand that when it comes to perform the deployment, I don't want that admin credentials should be used for deployment, because it's not safe or it's not secure thing. So what we do instead of that, we set up RBAC. So RBAC, like what exactly we have to do? So in RBAC, first thing that I'm going to do is create a account which we call as service account. You can understand it's basically a user. We created service account. So when you create a service account, by default it is having just basic permission or just like read permissions. It can read things, it cannot perform anything, right? After that, what we do, we create another resource inside the cluster which is known as role. Inside role, we define different resources like deployment, spots, services, and other things we define. Okay. And on these resources, we define level of permission. What kind of permission? Define permission that on these resources, if someone has this role available, they can perform view, edit, delete, update, anything they can do. If I show you an example, these are actually my course related docs, so I want to explain with respect to that. See, first what we have to do, we have to create a service account. So I'm creating a service account whose name is GitLab CICD SA, means service account, which is created inside a namespace named prod. So when you create this service account, by default this service account does not have much permission, just like read only permissions it has. Second resource that we create will be role. Inside role, we define first of all key for what namespace we are creating. Then we define different kind of resources like pod, services, secrets, config map, PVC, endpoints, event, and on those resources, what level of permission we are giving. You can see permission we are giving: get, list, watch, create, update, patch, delete. Every permission we are giving, right? Similarly, on deployment, stateful set, replica set, ingresses, certificates, all those things we define and different level of permission. That means ki whichever user is having this role available to them, they can perform these tasks on these resources. Next thing, sorry, next step, what we do, we assign this role that we have created with defined permissions to our service account. So assigning this role to our service account can be done by creating a third resource that is known as role binding. Here what we do, we create role bind and we define that this role should be assigned to this service account. If I show you the example, we create role binding resource. And here we define that uh, this role that we just created previously, this is the name of the role that we created previously, should be assigned to this service account in the namespace prod. So once we create this role binding resource, now what is going to happen, what is the result of this, now the service account, which service account, the one that we created, let's call it as GitLab CICD SA. Now this service account has permission inside the namespace prod to manage and like basically manage and do anything with the resources that we defined here. Now in everywhere you will notice one thing, here we have defined prod namespace. There are two kind of resources within cluster. One that is names space scoped. Secondly, cluster scoped. Namespace scoped resources are like they could be pods, deployment, ingress. These are resources that you create on the namespace level. But there are certain resources like persistent volume, storage class, cluster issuer. These are cluster level resources. So as of now, the service account we have created, it has permission to manage the resources that we just defined inside the namespace. But as of now, this service account does not have permission to manage any of the cluster level resources. So now what we do, we create two more resources. Now this resource will be known as cluster role. Inside this cluster role, we define cluster wide resources like storage class. We define persistent volume, storage class, cluster issuers, namespaces. And I want that this role I have defined, but this is the role on the cluster level. So I want that this permission on these resources should also be given to my service account. So for that, we have to create last resource, which is known as cluster role binding. That means ki now first I have to create cluster role where we have defined all the permission on cluster level resources. We assign this role to service account by creating third next resource, which is known as cluster role binding. And once this is done, then the service account that we have created, it has full permission to do deployments inside our prod namespace and create resources on cluster level as well, the one that is required. Okay, so that means ki as compared to our primary account, the admin user or admin credentials, and we have service account, this has all permissions everywhere, but this has permissions in prod namespace and few resources on cluster level also. That means ki this is now perfect for which we perfect user that we can use for deployment. Now what we do, we create a secret of it. Using and of this secret we create a token. Okay, now initially I told you ki when we have this kube config file for admin user, this can be used for authentication as well. So why not create the kube config file for our service account? That is, this kube config will be specific to the service account. So what we do now, we create kube config file for our service account. For that also actually I note down the steps. For that, what you'll be needing, first of all, you'll be creating a token, you'll be creating a secret of the service account, the one that we created. Once we create that secret, out of it we have to get the token. Once we have this token available, we can keep it. Next thing, in order to create the GitLab service account kube config file, certain things will be needing. First, cluster name. So my cluster name is DevOps cluster. Region, so for me, I'm in India, so I'll be using Mumbai location AP-South-1. Cluster endpoint, which will be like a cluster server, like server endpoint. For that, you could use AWS CLI command, AWS EKS describe cluster. You can get the cluster endpoint, and now you can see all these things you are storing inside separate kind of like variable. Then cluster CA. What is cluster CA? Cluster CA refers to cluster certificate authority data. This will be required and it is mandatory because this will be needed for the components inside the cluster to communicate among themselves, because this certificate will be used to verify ki, okay, this request is coming from a verified person or something like that. So this will be needed. Again, you can use AWS CLI command to get the certificate authority data as well. Final thing, again, the token for our service account, and again it is going to be base 64 d, sorry, it's encoded and decoded basically. Okay, so token also we have. Final thing we have to do, we can create, like we use a template. I have created this template, and inside this template certain values are replaced. You can see cluster CA, cluster endpoint, cluster name, then we have service account token, these things. So once you create this, this will be your GitLab kube config file. That means ki now we have the file that we could use for authentication for performing deployment. And when we use this file for deployment, that means ki our deployment is happening using our service account, and that is the best possible way, because now we are not using any kind of admin credentials. Okay, once we have done that, next thing what we have to do, see, this file will be available, GitLab kube config. If I show you, if I go to cluster, you can see this file, GitLab kube config. If I show you the contents of it, okay, let me show you. First, what we have, cluster name, cluster server URL, certificate authority data, users. This is something defined. This clearly mentions that this kube config file is with respect to this service account, and this is the token that can be used for like using the service account. Context also we are giving ki this kube config will be, this kube config file will be specific to uh, this cluster, this user, and this namespace only. And this context we are giving a name as GitLab prod. Next step, what we can do, we can go to our YAML file, and now we can add the code for performing the deployment. So I can copy this, and let me show you what exactly we have written here as well. Initially this might seem complex, guys, but in reality, you know, once you understand everything, you'll realize how easy it is, because the whole thing is about RBAC and kube config file. So once you know how to create or set up the RBAC, and you know how to set up the kubeconfig file, then you could use anywhere, because in any kind of CI/CD tool you could use kubeconfig file for deployment. What we are doing here, job name, this is the stage name. This time we are using this image. Now the reason for using this image is that it has the kubectl present. Kubectl is what? It's the CLI using which we can communicate with our cluster, right? We are using entry point, this entry point empty, because if I don't use this, then by default kubectl will get executed and it is going to cause issues, because by default we want that only shell should be executed as the entry point. Okay, because how do I know? I just, because I was facing issues, then I figured out, okay, this is what we have to do. So make sure to add this. Then we have to write the actual script. First thing what we have to do, the kubeconfig file that we have set up for our service account, that we need to convert into base64 encoding. If I execute this command, it's, see, as of now you can see it's YAML format, right? What we have to do, first of all, we have to encode it into base64, and this is the format you will get. Once you get the base64 encoded format, you can go to CICD variables, and here you have to add in the kubeconfig data. Here you can add that encoded format. Next thing what we are doing, first of all, we are getting the value of it, then decoding it, and then pasting it inside a new file known as kubeconfig. And then we are exporting kubeconfig file. We are telling that now this is the kubeconfig file that you have to use. And then we are setting up the current context also. Setting up context means we are defining this is the kubeconfig. Inside this kubeconfig, whatever things we are defined, that we are going to use. Okay, getting namespace information, getting what ports are available, and finally whatever manifest file we have inside this 𝗬𝗺 file, that we are going to perform the deployment of. If I show you here the YAML manifest file, I'm not explaining it right now because it's going to take very long, because so many files we have created. You can see these are the manifest files. First we have backend. I'm using 3 pods for 3 replicas for the backend. You can see updated image tag. Okay. Then we have front end. We have cluster issuer. We have, because of which we are going to get the certificates, SSL certificates. Ingress we have. Okay, let me quickly show you what exactly we have to do. So once you have created cluster, make sure that first of all, before any deployment, you are deploying your storage class, because if not, then the PV or the persistent volumes won't be created. So make sure that you are creating this storage class first. After that, what we have to do, after that, rest of the things you can deploy. Okay, so after deployment, what is going to happen? If I show you, after everything is deployed, first thing you have to do is run the command kubectl get ingress -n prod. Here you'll be, one second, let me make it smaller so that it's visible properly. So when you search the ingress for your project namespace, you'll be able to get an address. Why this will be needed for us? Because we want to map our project with a custom domain. So basically I have a domain available as adityajaiswal.com. So I want that anytime anyone search on Google as adityajaiswal.com or www.adityajaiswal.com, my application should pop up. How we can do? First of all, you have to copy this address of ingress, go to your domain and domain like DNS record of your domain, scroll down to CNAME. Two record you need to understand very clearly, A record and CNAME record, and let me explain you why. First we have a name record, sorry, we have A record and we have CNAME record. Now, when you create load balancer URLs using EKS cluster, you get a URL. you don't get an external IP. For example, here you can see when I created ingress, utilized ingress, I got a URL. So when you receive URL, you have to add that URL inside CNAME record, and CNAME record is specifically for www. So here we can add URL. But when you are deploying your application to Azure Kubernetes cluster, what you get an external IP. So that you can add with @ and external IP. But you might ask this, ki Aditya, in a record we are not getting URL. Then how www will be done? So if you are working with AKS, you have to write in this format. See if I show you. If you are working with AKS, so you'll be getting just external IP. So here you have to create a record, name @, then paste the IP that you get. Second, you have to click on add new record, create a record. Here you have to write www, add the external same IP and save it. In case of CNAME record, where we are getting just an URL, you have to run the command ns lookup and the URL. It's going to give you the IP associated with the URL. So once you have this IP, then what we can do, first of all, in CNAME record with www, you can add the URL, and then you can create a record with @ and paste the IP that you got. Which IP I'm referring to? The IP that we got using nslookup by running nslookup command on the address. So this IP that you see, that we can add to our GoDaddy platform in a record and then save it. Once you do this, then you have to propagate. We have to wait for some time. For example, and then you can go to this website. You can see when I click on this @jdeswal.com in a record, it's giving tick marks. Most of the tick marks are there. Here, if I add www dot and here I go to CNAME and click on search, it's going to give the exact ingress address URL that we have just created. One more thing that you might face issue with respect to your deployments is that the SSL certificate. As of now, if I show kubectl get certificates -n prod. So as of now, certificate status is true, but it won't come immediately online. What you have to do, basically, when we create the certificate, so by default, we should be creating the cluster issuer before any of these deployments. But I have done like directly. So in that case, one thing that we could do is delete the TLS secret, and delete the certificate request. Reason that we have to delete it, so that new one can be created or new like regeneration can be done. Because if we don't delete it, then like certificate request will be always in pending. But we want to immediately delete it so that it can start fresh, and then certificates will be generated and it will be available in like 10-15 minutes. You can see now it shows true status, and then only your application will be accessible on proper custom domain with HTTPS. This is how you have to do. Okay. uh, let's take questions, guys. I'll upload this video on YouTube as well. Yeah, Sumit has asked, do we not have to install Java to run SonarQube execution? So Sumit, the thing is ki Java might be the prerequisite, but the thing is ki the Docker image we are using, which has the Sonar Scanner CLI, it will be having Java already installed. Plus server we have set up, so that we have set up using Docker container. So there also, if it is required, it will be there. Yes, Sumit. So why do you need to provide GitLab pad to clone the repo? Till yesterday, everything was working fine without any pad token. It was working fine for me. But today itself, I was seeing that some issue is happening. For that purpose, just to make sure ki I can show you the demo, it is working fine. I just added the pad token for cloning. Git leaks. What is Git leaks? Git leaks basically refers to Git leaks is a tool. What it can do, sometimes it happens that many developers by mistake, or some new developers that might not be aware, they hard code some sensitive data, for example, like some kind of token or some kind of API key. They might hard code in the repository. So in order to find out immediately before we perform the deployment key our repository has any kind of sensitive data or not, we can find out that information using git leaks. Idris DevOps course batch 12 has already started. It has recorded content plus more content will be added, plus dedicated doubt support is there. If you have any queries or doubts, you can put in Discord server. If you want resume reviewed, you can ping me directly. You can connect with me. If you have interview scheduled, that also you can ask me to connect. Okay. Okay, guys, I will be uploading this video on YouTube as well. So make sure to check out that as well. Janak, it's not कि I choose to use GitLab CID, CICD. I use, let me just show you directly. One second. I hope my screen is visible. So if I show you, yeah, you can see this is my GitHub Actions project. This is also is added in my course. Here also same kind of steps I have included. If you can see clearly, same kind of steps are there for deployment. If I show you the pipeline stages, with GitHub Actions, it's little bit easier to write everything. But the same kind of stages I have added here also. Hey, the only difference that was coming, mm, 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 yeah, one main difference that was coming, like we were going inside the loop, we were going. Mm, 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 mm. So in GitLab CI/CD, we have to use skip CI to skip the updating, skip this triggering of the pipeline. But in case of GitHub Actions, when you are pushing changes to GitHub repository using the GitHub Actions, not going to trigger the pipeline. Ashish Yadav, in batch 12, do we have sufficient Python content to crack from DevOps interview point of view? Ashish, I would highly recommend to check out this syllabus. In that, I have added in detail what exactly we are covering. So from and that Python section is covered strictly from uh, DevOps point of view. You can check out the syllabus; it will give you more clarity. Okay, and all the details will be in description. If you have any query, you can ping on WhatsApp, guys. I am giving you contact also. You can ping there 30392. So you can ping on WhatsApp if you have any query related to course. And yeah, I'll be doing more live sessions maybe on GitHub Actions as well. So we'll see you then. I hope this was useful. I'll be adding this video on YouTube as well. Okay, guys. Thank you everyone, and have a nice day.